In this video, I've decided to sketch the equation, and I'm going to show you how to sketch the equation for quadratic functions. It is very important, especially if you have been asked to find the normal equation to the tangent, because you need to have a clear picture of what you are looking for and why you are using the method which you want to use. That's what mathematics is all about. It's about understanding, okay? Not just memorizing things, okay? And that's what I want you guys to be. Be that person who solves and understands mathematics, not someone who only memorizes. Alright, so let's get started. I want to show you first how I got these coordinates that I used to sketch my graph, right? Okay, so what you need to find is just three things. You need to find the y and the x-intercept, okay, or intercepts. The y and the x-intercepts. That's what you need to find. All right, so these are the two important things, and apart from that, you also need to add you need also to find the vertex. Okay, you need to find the vertex. Very important. Okay, so let's do that and see how I got these points. So to find the y-intercept, you need to let your x be equal to 0 in the equation there. If your x is equal to 0, you see that your y is going to be -4. That means your y-intercept is at the point where x is equal to 0 and y is equal to -4. And this is where your graph is meeting the y-axis. And this is the point you can see right there on the graph. Now next, we need to find the x-intercepts, right? So our equation, since we are using the equation here, there was just a mistake here. This positive here, it's supposed to be a negative. All right, okay, that's it now. So we have x squared minus 3x plus that's -4 again, right? So we are letting this equal to 0. So we are letting y to be equal to 0. And then you can solve this any of the methods you can use. Some would choose to use completing the square method, others will use factorization. You are just going to get the same answers, right? So whichever method you are going to use, just make sure you get the same answers, right? So if you use the sum and the product method, you are going to have something like this, right? That's -4 is equal to 0, right? And then when you factorize here, you are going to get that's x. Should I show you this, or you know what to do from here, right? So you're going to get x -4, right? And then you're also going to get x plus 1, right, is equal to 0. So whichever method you use, and this will give you x is equal to, that's +4, or right, x is equal to -1. So that means your y-intercepts, you have for the value of y is equal to 0, you have at the point where y is equal to 4, okay, and at the point where x is equal to y is equal to 0, you also have x is equal to -1. So you have -1, 0. So these are your x-intercepts. Okay, are you able to see this on the graph there? Yes. So once you have your x-intercepts, you can draw the points there on the x or y plane, right? Okay, you're about to connect now the points. The next thing is to find the minimum value or the vertex, right? So you find that by using the formula y is equal to negative b, right, over, right, that's what we have, negative b over 2a. Okay, now when you substitute here, you see that your b is negative 3, right, which will give you positive 3 over, now your a is 1, right, that's positive 1, so you're just going to have 3 over 2, right? And now you can, if you want to find now the y value to this x-intercept, I mean to this vertex, you need to this minimum, the x value of the vertex, you need to substitute 3 over 2 into the equation so that you can find your y value, right? So your vertex now is going to be with the x value of 3 over 2, right? And the y value of negative 25 over 4. So this is your vertex, right? That's this one. So these are the 3 things you need, and you can sketch your graph. So you have all the 4 points there, and all you need to do is just to connect using a pencil if you're using a paper, okay, yeah, whichever method you use. These are the points that you need to find the x-intercepts, the y-intercept, and the vertex there. Then you can draw a quadratic equation graph. All right, now let's solve our question. Okay, I was just showing you how you can graph, and we are going to use this as we solve, right? Graphing is very important because sometimes you may be asked just to graph, okay? And then when you graph something, okay, it becomes easy for you to see things clearly. It makes you understand mathematics. Like I said, you need to be students who are able to understand mathematics, understand what is happening, why it is happening, why you are doing the way you are doing it, why you are using the method you are using to solve. And that's what mathematics is all about, right? All right, so let's now proceed there. If you have any question regarding how to sketch or draw graphs of polynomials, quadratic, cubic functions, you can just request for a video. You can use the email right here on top, okay? You can also subscribe to my YouTube channel so that I can get in touch with you guys. All right, so we need to find the equation of the tangent, okay, to this curve, okay? So what we are going to do, I think let's just get this equation, right? Let's just get this so that we can have space down here. So we want the equation of the tangent to this curve right here. Okay, so we use the second graph later, okay, not now, so you can just ignore it for now and focus on how we'll be solving. So what we need to do here is to remember that we have been given the point, okay, where we want to find the equation of the tangent, right? It's where x is equal to 2, right? So we can use this equation that we've been given to solve for the y value at this point where x is equal to 2, right? So if you do that, you are going to substitute, okay, in your equation there and see what you are getting. There you have minus 4, right? And what are you getting if you solve this question? So you can just check it out and make sure you are getting the same thing, right, that I'm getting. And you see that all you are getting is negative 6, here, right? So that means the point, okay, at which you want your tangent is at x is equal to 2. That's 2 comma negative 6, right? So this is where you have your tangent. This is the point where you have your tangent. Okay, now you need to find the equation for this tangent. Okay, so we have the x value there and the y value. Good. Sorry about that. Then the second thing we want to do is to find the gradient at this point. Okay, and remember from the previous video, how do we find the gradient? You need to find the first derivative of your equation, okay, the equation that you have. Okay, so we want to find dy over dx. Okay, so we want to find dy dx. Now our y is nothing but the equation or the expression x squared minus 3x, right, minus 4. So differentiating this gives us what are we getting here? Okay, so that means we are getting, that's 2x, right? So we're just getting 2x minus 3, right, as the first differential of our equation, right? Now the next thing we want to do is, since we want to find the gradient at the point where x is equal to 2, that means this expression that we've gotten, okay, write this one. After differentiating our equation one time, we are going to substitute this by, we're going to substitute the x variable by 2, and that gives us the value of the gradient, because gradient is equal to the first differential of the equation that you have. Okay, so if we do that, let me do this so that we can, so this is the equation of the gradient, right? So we can just say this gives us the expression for the gradient, and if we subtract, okay, if we substitute this expression by 2, that's positive 2, this gives us the slope size. So that is, we have 2, we have 2 there, minus 3, and that gives us the gradient as positive 1, right? So this is our gradient. Now that we have our gradient, we can finally write the equation of the tangent, right? So the third step now is to write your equation. Remember, you use the formula y minus y1 is equal to m, which signifies your gradient, that's x, minus x1, right? Okay, that's x minus x1. So you can substitute there your x1. Remember, you have found this point here, right? Right here, check it out. We found this point here, right? We found our x and our y value, that was 0 comma negative 4, right? So we're going to use that value. Wait, just a moment. All right, we haven't found this point. We found it. Where is it? Okay, it's right here. It's right here. Okay, so at the point where x is equal to 2, we found y to be negative 6, right? So we're going to substitute that. So y, we're going to substitute that by negative 6, right? And then we have our gradient, which is just positive 1, and then we have our x, and then we have our x1, right, which we found, we've been given, in fact, that one to be 2, right? So we have positive 6 is equal to x minus 2, and that gives you the equation of the tangent which you are looking for to be x minus 8, right? That's x minus 8 as the equation of the tangent you are looking for, right? Now read through your question again. It says, hence find the equation of the normal, right, to the tangent. So at this point where x is equal to 2, not only do we have a tangent but also a normal line. Okay, now if you remember what a normal line is, so this line I've drawn here, okay, we have a point 2 comma negative 6 where we have a tangent, okay, and this is the line, the tangent line, a pink one which you can see. Okay, now we have a normal line, so here you need to understand something. We want to find the equation of the normal line to the tangent. Now remember, a normal line is perpendicular to the tangent line, right? And that gives you an idea of what you're supposed to do, right? So if we draw a normal line here, I'm just going to make it dotted here, and see that our normal line there will be perpendicular to the tangent, right? Okay, so this is the normal line which is perpendicular to the tangent. Okay, so now you need to remember, if this normal line I have in blue is perpendicular to the tangent, the line in pink, then the gradient of the tangent, which we'll call to be normal m1, okay, the gradient of the tangent, okay, if I multiply that gradient of the tangent with the gradient of my normal line, right, which we'll call 2 to represent the gradient of the normal line, my product should be negative 1, right? Should be negative 1. Very important to remember that. Okay, now that you have this to be negative 1, right, that means the gradient of a perpendicular line for this situation here, okay, for this property to be satisfied, remember you've just found your gradient for the tangent, right? At that point the gradient is positive 1, right? Now at this point where you have a gradient of positive 1, there is a normal line which is perpendicular to the tangent, and that tangent line has a gradient of 1, right? Which means the gradient of a perpendicular line, which we are calling m2, okay, should be positive 1. For this property to satisfy, that is the product of your tangent gradient, the product between the gradient of your tangent line and your normal line should be negative 1. Now if m1 is positive 1, then m2 should be negative 1, right, for this to satisfy. So that means our m2, which is the gradient, right, the gradient for the normal line, right, I'll put n to mean normal line, its gradient, which is m2, is negative 1. Cool. So since it's negative 1, the gradient, then the point remains the same. The point we are still using 2 comma negative 6. This is the point where we have a normal line, right? So we have the x value there at this point and the y value and the gradient of the normal line. So it is now easy to find the equation of our normal line by using y minus y1, right, is equal to m open bracket x minus x1. So this is just one and the same. all you needed is to understand what the question meant. And you can see how sketching the graph has made things easy for us to understand what this question meant, right? So it's very important to draw something when you're answering questions like this one. It's very important. So we have our y1 will be 2, our gradient is -1, right? And we have x there, and we have -6, right? Okay, so you can just see what this will give you. Okay, so look at this. We're going to have y is equal to, you have -x, right? Plus 6, that's -6, right? That's -6. Just a moment. So you have -x, -6, and then plus 2. Okay, just confirm this is true. So you're going to have y is equal to -x, right? Minus 4. Okay, so this will be the equation of your normal line to the tangent at the point where x is equal to 2 and y is equal to -6. So this can be simplified further and can be written as negative, can be factorized, and you have positive 4. So this is the equation of your normal line.